So welcome. So in this video I'm going to teach you about valency of elements and also radicals. So what is important is that we need to know and define what does this word valency mean. So when we talk about valency, we can simply say it is simply the combining power that defines the number of electrons that form an ion. Yeah, so that can either be positive or it could be negative. So we are simply saying that valency is the combining, so the combining power that defines the number of electrons. So the number of electrons that form an ion. That is what we simply call as being the valency. And of course, sometimes when we talk about the valency, an alternative word that we can use for valency is we can simply say combining power. So that's an alternative term that we can simply use. But what I want you to remember is that valency is simply the combining power that defines the number of electrons that form an ion. For example, if you look at sodium ion, it is like that. So in this case, the combining power, that there's a 1 here, meaning that because there's a 1 there, it simply means that sodium has a valence of 1. If you look at calcium ion there, look at the combining power, it's a 2, meaning that it has a valence of 2. If you look at lithium, it has that, it tells you that that has a valence of 1. You can talk about also non-metals like oxygen, it has a 2-, that tells you that it has a valence of 2. If you look at fluorine, it has a valence of -1, that tells you it has a charge of -1, that tells you it has a valence of 1. If you look at nitrogen, it has got a -3, so it tells you that it has actually a valence of 3. So you can look at this, it in this way. So the combining power that defines the number of electrons that form an ion. Now for elements, you don't need to actually struggle when it comes to elements. Let me quickly, tell you about elements. Of course, some other books will actually define valency as simply the number of electrons lost or gained or shared by an atom of the element in order for it to attain a stable structure. That is also fine. You can actually define it also in that way, but I'm going to summarize it for you nicely. So when it comes to elements on the periodic table, you don't need to waste time. Remember, elements on the periodic table are categorized in 2 groups, so you can easily tell what we are calling as being the valency of a particular element on the periodic table. You don't need to actually start wasting time. Let me say that maybe that is representing the group, then let me say the valency. So from the periodic table, how can you tell the valency of a particular element? So if you can be in group 1, you can be in group 2, you can be in group 3, you can be in group 4, you can be in group 5, you can be in group 6, you can be in group 7, or you can be in group 8, or as you call it. Now, of course, remember that these sometimes are actually given as you advance. They may call it 1, 2, and they may call this one as being 13, 14, 15, 16, 17, 18. That's the way they may call them, but don't worry about that. So we are going to stick to the Roman numerals that we use. So if you're in group 1 on the periodic table, it simply means that an element has a valence of 1. Group 2, a valence of 2. Group 3, it simply means that it has a valence of 3. For group 4, it simply means that it has a valence of 4. Now, in most cases, when you look at those that are found in group 4, these guys, they love to basically, share. That's what we know. So they love to share, and therefore the valence, when they are forming a bond, they love to share, and therefore the valence will be a 4. Now, for those that are found in group 1 to 3, these basically are metals, and metals form up what we call positive charges. They form up a positive charge. No wonder when we write, for example, an element in group 1 like sodium, we may write it as N+. Remember, it has a valence of 1, but it's positive because they give out, metals actually give out electrons. If you look at things like magnesium, we may write it as a 2+. You can see the valence is a 2 because it is found in group 2. It is actually positive. And starting from group 5 to somewhere, going this side, all these are what we call as being non-metals. So for non-metals, they simply possess negative charges. So how do you account for the valency of non-metals? Well, if you want to account for non-metals, the valence for non-metals is simply the difference between group 8, and the group number of the element. For example, those that are in group 5, so you just say 8 minus the group number where the element is 5. So 8 minus 5 will give you a 3 there. That's what we know. So this one, group 7, so 8 minus 7. So these in group 6 have got a valence of, they have got a valence of 2. Those in group 7 have got a valence 8 minus 7 is a 1. But remember, these actually carry negative, they carry negative charges. That negative simply tells you they gain actually electrons. That's the whole idea, about it that you need to remember. For those that are found in group O, what is the valence? What do you think will be the valence of those that are found in group O? Of course, for those that are found in group O, we can simply say it is 0. In other words, these guys are actually stable already. Let me just use the word, they are actually stable in this case. So we don't actually assign, in this case, their valency. But if you want, we can simply say their valency is actually a 0 there. So you need this in order for you to write what we call chemical formula. So once you know how to you understand about valences, then it actually becomes very easy when it comes to writing formula. So on the periodic table, I don't expect you to have any problems when it comes to identifying, valences. So in my next video, I'm going to talk about how, to deal with radicals, a group of atoms, that come together. But how do you assign the valency? So in my next video, I'm going to talk about that. Watch out.